We are given that this blue region is a square. We have a 10-degree angle and a 90-degree angle. And we need to find the angle alpha. Let's start with calling this angle as beta. Then alpha plus beta will be 90 degrees. Since the blue region is a square, this red angle is 90 degrees. We know that alpha plus beta is 90 degrees, so this angle must also be alpha. Similarly, this angle will be beta degrees. Now focus on this triangle. We know that this is also a right angle. So the remaining angle of this triangle must be beta degrees. Now focus also on this triangle. And notice that both triangles have a 90-degree angle, an alpha degree angle, and a beta degree angle. And so we can say that these triangles are similar triangles. Now pay attention to the sides opposing beta degrees in both triangles. These blue line segments are the sides of the square, so they are equal. And so our similar triangles are actually congruent, and all corresponding sides must be equal. So let's see the sides opposing 90-degree angles in both triangles. We know that they must be equal from congruency. Now focus on this triangle. And notice that this is a right-angled isosceles triangle. Therefore, its base angles must be 45 degrees each. Now, if we focus on this angle, we can see that beta is the sum of 45 and 10 degrees. And so, beta will be 55 degrees. We know that alpha plus beta is 90 degrees. So alpha can be found as 35 degrees, and that is our answer. In the next question, we have a square, and lengths of the two line segments are given. And we need to find the missing angle alpha. We know that squares have 4 equal sides, so these two sides will also be root 2 units. Then let's draw this diagonal of the square. And remember that diagonals are also angle bisectors in squares. So these angles are 45 degrees. Now focus on this triangle. We can apply Pythagorean theorem to find the length of the red diagonal. And from here, AC will be 2 units. Now focus on this triangle. And notice that 2 of its sides are equal. So this is an isosceles triangle. And that means corresponding angles to equal sides must be equal. And so this angle should also be alpha degrees. Now we can use exterior angle theorem on this triangle to see that 45 is the sum of 2 alpha degrees. So alpha will be 22.5 degrees. And that is our answer. In the next question, we have a square with a side length of 12 root 2 units. We are given a 45-degree angle and a 7-unit line segment. And we need to find the length of the red line segment. To start, let's draw this diagonal of the square. And remember, all sides of the squares are equal, so this side will also be 12 root 2 units. Now focus on this triangle. We can find the length of the diagonal by using Pythagorean theorem, or just simply take one side of the square and multiply it by root 2. And that will be equal to 24 units. We know that diagonals of the squares bisect the 90-degree angles at the corners. So this angle must be 45 degrees. And so the total measure of this angle will be 90 degrees. Now we can apply Pythagorean theorem on this triangle. And from here, the missing side length DE can be found to be 25 units. And that is our answer. In our next question, we have a square ABCD. We are given two side lengths of 10 and 4 units. And we need to find the missing length x. Let's first call this angle as alpha and this angle as beta. So alpha plus beta will be 90 degrees. Now extend this line segment and drop a perpendicular to this from point C. We know that internal angles of squares are 90 degrees. So this angle must also be alpha degrees. And so this will be again beta degrees. Also notice that this shaded region is a rectangle. So opposite sides must be equal, and we can write x plus 4 for the length of the line segment CH. Now focus on these two triangles, and notice that they are congruent triangles. And so sides opposing same angles must be equal in length. And from here we can write x plus 4 must be equal to 10. And so x will be 6 units, and that is our answer. In the last question, we are given a square. These two line segments are equal. We have two 90-degree angles, and we are asked to find the ratio of line segments AE and EB. First, let's call the length of these equal line segments as 4k each. Then one side of the square will be 8k. Then let's call the internal angles of this triangle as alpha and beta. So alpha plus beta will be 90 degrees. Then focus on this triangle. Since alpha plus beta is 90 degrees, this angle must be beta. And so this angle will be alpha degrees. Now notice that these two blue triangles have the same internal angles. So they are similar triangles. The triangle on the right has a 8k side opposing alpha degree. The triangle on the left has a 4k side opposing its alpha degree. From here, we can say that the similarity ratio is equal to 2. In the triangle on the right, we have a 4k side opposing beta. Since the similarity ratio is 2, the side opposing beta on the other triangle must be half of 4k, and that is 2k. We know that the side of the square is 8k. So this part must be 6k. Now let's focus on this triangle. As before, since alpha plus beta is 90 degrees, this angle must be beta. So the remaining angle will be alpha degrees. And so these orange triangles are also similar. So let's find the similarity ratio. In the upper triangle, the side opposite alpha degree angle is 6k. So let's write that for the numerator. In the lower triangle, the side opposite alpha degree angle is 4k. And let's write that for the denominator. And so the similarity ratio of these two orange triangles is 3/2. Since the side opposite beta degree angle in the lower triangle is 2k, the side opposite beta degree angle in the upper triangle must be 3k. We know the side length of the square is 8k. So the remaining part of the top line segment must be 5k units. Remember that we are asked the ratio of AE and EB. Now we know that AE is 3k and EB is 5k. So our answer to the last question will be 3/5. I'll see you next time.